So although these two triangles have equal area, triangle ABC is not congruent to triangle PQR. Okay, but if two triangles are congruent, then definitely you can say that the areas are equal. Okay, this is what is meant by congruence area axiom. Now equal figures. What do you mean by equal figures? Equal figures means if two figures have equal areas, then they are said to be equal figures. Geometric figures, obviously. If two figures have equal areas, then they are said to be equal figures. Okay, fine. Now with these two concepts, we start with the first theorem on area. Theorem number 1. The theorem is a diagonal of you have already done this theorem actually. A diagonal of a parallelogram divides it into two triangles of equal areas. So this is just a revision. You have done this under rectilinear figures. A diagonal of a parallelogram divides it into two triangles of equal areas. Okay. So if I give you, let's see, draw a parallelogram. And you have a diagonal. So given is ABCD is a parallelogram with AC as one of its diagonal. Then you will conclude that triangle ABC must be congruent to triangle ADC. Okay, that means this triangle and this triangle will be congruent. Similarly for the other diagonal also. Okay, so this is the first theorem. Okay, the next theorem, and a very important theorem, is that parallelograms on same or equal base, parallelograms on same or equal basis and between the same parallel lines must have equal areas. Okay, what does this mean? Let's say I give you a parallelogram and This is the figure given. If you see in this figure, ABCD is a parallelogram. See, these two are parallel lines. These two are parallel lines, and these two are also parallel. So if you see ABCD is a parallelogram, and if you see ABQP is also a parallelogram, given parallelogram ABCD and parallelogram QP are on the same base. Which one is the base? Which one is the base? You see AB is the base, they are on the same base, right? And between what parallel lines? If you see AB and DQ are parallel lines, right? So AB parallel to DQ. Now check whether you have understood this figure. Can you see both the parallelograms? ABCD and ABQP? Can you see the two parallelograms?
Yes, sir.
Yes, sir.
These two parallelograms are on the same base, right? AB. If you see, they share the same base, AB. And they are also between these two parallel lines, this parallel line and this parallel line. What does the being between two parallel line means? Being between two parallel lines means that the height of these two parallelograms are the same. That is the distance, the perpendicular distance between these two parallelograms are the same. That means the height of both the parallelograms are the same. Okay, let me write here. Height, base is same, and height of both parallelograms are the same, are equal. Okay. In such a case, when the two parallelograms are on the same base and between the same parallel line, that is the heights are the same, then you can conclude that area of the two parallelograms must be equal. Area of parallelogram ABCD must be equal to area of parallelogram ABQP. Okay. Now, if you see in the statement of the theorem, I have given same or equal. The first one, this figure is for same base. Let's see what happens if the parallelograms have equal bases. Let's see how the figure looks like first. You see that here ABCD is one parallelogram, right? And PQRS is another parallelogram. Okay, so let's mark the parallel lines. These two are parallel. Also, these two are parallel. Also, these two are parallel. Right? Such that if you see the base of the parallelogram ABCD is AB, right? And the base of the parallelogram PQRS is PQ. Now, what if I give you these two bases are equal? So given here are parallelogram ABCD and parallelogram PQRS are on equal basis. AB equal to PQ, that is given to you. Okay. And between what parallel lines? If you see, this is one parallel line SC and the other parallel line is PB. Okay, so these two parallelograms are not on equal basis, not on the same base, but they are on equal basis. Length of the bases are equal, right? And they are between these two parallel lines, SC and AB. That means the height of the parallelogram is the same. Your conclusion will be the same, that area of the two parallelogram must be equal. Area of parallelogram ABCD must be equal to area of parallelogram PQRS. Any question here till this part? Any question on the two figures? No
Excuse
question?
me, sir.
Go ahead.
Sir, can you please scroll up? Sir, more up. Yes, sir. Thank you.
Fine, no question? Okay. So this was an important theorem. And remember that if I have a parallelogram and rectangle on the same base, will they have equal areas? Now, this is my question to you. If I have a parallelogram and a rectangle on the same base, will they have equal areas? Suppose I give you this figure. ABCD is a parallelogram. And AB PQ is a rectangle. Will they have equal areas? Can you tell me, will they have equal areas?
Yes, sir.
Why?
Sir, because they have same base.
So what? One is a parallelogram, one is a rectangle. I said two parallelograms. I did not say one parallelogram, one rectangle.
Sir, rectangle is also a parallelogram,
Exactly.
but of
Rectangle is
90
also a special kind of a parallelogram. So if I say two parallelograms, it can mean rectangle and parallelogram. It can mean rectangle and a square also. It can mean parallelogram and a square also. Okay. So squares and rectangle, they are special cases of parallelograms, right? So they are on the, you see that they are on the same base AB, right? And also they are between the same parallel lines, right? Between which parallel lines? QC, parallel to AB. Then what can I say? My conclusion will be that area of parallelogram PQRS, ABCD, must be equal to area of rectangle ABPQ. Okay, because rectangle is also a special kind of a parallelogram. Okay, so if a square and a rectangle are on the same base and between the same parallel line, will they have equal area?
Yes, sir.
Yes, because both are also parallelograms. Okay, so once we have finished this, an important theorem, we move to the converse of theorem 2. Converse is actually not too important, but still I'm just mentioning. Converse of this theorem is, if two parallelograms have equal areas, if two parallelograms on the same base have equal areas, then they must be between the same parallel lines. They must lie between the same parallel lines. What do you mean by lying between same parallel lines? That their heights must be equal. That is, their heights must be equal. Yeah. So if I give you, I think it does not require explanation. I think the converse is okay, not too important. Okay, so if I give you two parallelograms, if I tell you that they have the same base and they also have the equal area, then you must conclude that their heights must be equal, or they must lie between the same parallels. Okay, fine. Next theorem, Theorem 3. Is that this is a very important theorem, that area of a triangle is half that of a parallelogram is half that of a parallelogram on the same base and between the same parallel lines. On the same base and between the same parallel lines. Right? I'll give you two figures in this regard for you to understand. Let's say this is one figure, ABCD, and let's say this is another. Let's call it the same, give the same name, but the construction of the figures will be a little different. We'll call this point P. Okay, let's call this point P. Okay, so I give you parallelogram ABCD and triangle ABP are on the same base. Let me specify the parallel lines also. So parallelogram ABCD and triangle ABP are on the same base. What is the base here? In both the cases, you see that AB is the base, right? The parallelogram ABCD is on the base AB and the triangle ABP is also on this base. Similarly, for the second figure, triangle ABP and parallelogram ABCD are on the same base. And also, if you see, they are between the same parallel lines, right? These two parallel lines. Between the same parallel lines. What do you mean by a triangle and a parallelogram being on the same parallel line, between the same parallel line? It means that is height of the parallelogram and the triangle are equal. Okay. Now, what is the height of this parallelogram? If you drop a perpendicular from here, this will become the height, right? Isn't it? And that is also the height of the triangle. Now, in the second figure, which one is the height? If you produce this side, here is this, and if you drop a perpendicular from here, let's call this PM, point M. If you see, PM is the height of the parallelogram ABCD, and PM is also the height of the triangle, right? Any problem with observation that PM is the height of the triangle, of both the triangles? No problem. Lying between the same parallel line simply means that the heights are equal. Okay. So in this case, the parallelogram and the triangle are on the same base and they also have the same height. That is, they are between the same parallel lines. Then I can conclude that area of parallelogram ABCD for any of the figures that you see, area of parallelogram ABCD must be equal to half, or let's say area of triangle ABP must be equal to half area of parallelogram ABCD. Any question here? Tell me. With the figure.
No, sir.
Okay. Deduction from this, or a corollary to this theorem, corollary to theorem number 3 is corollary means what? A deduction, right? Corollary to theorem 3 is that a median of a triangle. What do you mean by median? Anyone tell me, what do you mean by median? Divides it into two triangles of equal area. You can deduce this from this theorem. Now, anyone can tell me what you mean by median? I told you what is the definition of median. I think when I was doing coordinate geometry, I told you. You take the midpoint of any one side, right? Let us call this P. And what you do is, from the opposite vertex, you draw a line segment joining this middle point, the midpoint. That is, this must be equal to this. A median of this AP is called the median. So in order to construct a median, you take the middle point P of any side, and from the opposite vertex, you draw a line joining the midpoint. Then that straight line is called the median. Okay. Similarly, how many medians are possible in this triangle?
So
How many
3.
medians? 3 medians are possible. Okay, I've drawn only one just to show you. Okay, so if I give you that AP is a median of triangle ABC, then you can conclude that these two triangles, ABP and APC, must have equal area. Area of triangle ABP must be equal to area of triangle APC. Very important theorem. That the median always divides the triangle into two triangles of equal area. And this can be proved very easily also. Can you prove this with the help of congruent triangles? Is it possible for you to prove this with the help of congruent triangles?
Yes, sir.
Yes,
Yes,
sir.
we can prove this very easily also. Okay. So this is one deduction from this theorem. Let us see the next theorem. Okay. Also an important theorem, theorem 4. Triangles on the same base this is theorem 4. Triangles on the same base and between the same parallel lines must have equal areas. Okay, let me write this here. But what do you mean by between the same parallel lines? That is, they have the same height, right? They have the same altitude. They have the same height. Must have equal areas. Okay. What does this mean? If I give you two parallel lines, right? And in these two parallel lines, I dot triangles between these two parallel lines. Okay. Fine. And not only equal, but let me write equal bases also. Not only same base, but or equal bases. And so triangles on the same base or equal bases and between the same parallel lines. Let us first discuss the case where you have equal bases. Let us call this triangle ABC. And let's call these 2 points P and Q. So clearly in this figure, you can see three triangles are there. What are the triangles? Triangle ABC, triangle PBC, and triangle BQC are on the same base. What is the base here? This is the base, right? Are on the same base and between what parallel lines? PQ parallel to BC, right? Now, as I told you, between the same parallel line means they must have equal heights. So what are the heights of the triangles? This is one height. Of this triangle, this is the height. And of this triangle, which one is the height? You drop a perpendicular from here. This becomes the height. So that means between the same parallel line is nothing but saying they have the same height. Okay. Your conclusion will be that the areas are equal. Triangle ABC. Area of triangle ABC must be equal to area of triangle PBC must be equal to area of triangle BQC. All these two triangles must have equal areas because they lie between these two parallel lines and they share the same base BC. Is this clear or any question you have?